Hello, this is Geometry, topic 2-2, just more on points, lines, and planes, continuing from topic 2-1. And so here are some important facts that we need to know. 2 points determine a line. What that means is if I have 2 points, there is a line that connects those 2 points. And so in order for me to have a line, I need to have at least 2 points. Now, 3 non-collinear points determine a plane. Okay? What this means is if I have 3 points and those 3 points are not all on the same line, then I have a plane. If they are on the same line, then I still just have a line and I can't determine the plane from that. Now, actually this should not be 3 non-coplanar points. This should be 4 non-coplanar points determine a space. Because the thing is if I have 3 points, they will always be coplanar. Okay? So that means in order to determine a space, a 3-dimensional space, I'm going to go ahead and write 3D space. Okay? In order for me to have 3D space, I have to have at least 4 points, and they have to be not in the same plane, because any 3 points make a plane. Now, the intersection of 2 lines is a point. I apologize for that space right there. I was just trying to think intersection of 2 lines is an intersection, but no, more specifically, if I have 2 lines, the point where those 2 lines cross is a point. Now the intersection of a line and a plane, so here I've got my plane, and then I've got this line that cuts through the plane. They intersect at a point. And the intersection of 2 planes would be a line. And it's kind of hard to see, but where these 2 planes cross is a line. So 2 points make a line, 3 non-collinear make a plane, 4 non-coplanar determine a 3-dimensional space, 2 lines intersect at a point, a plane and a line intersect at a point, and 2 planes intersect at a line. So let's see what we know for example number 1. Okay, things we know from the picture. Well, x, b, and y, they're not collinear because they're not a line, so that would tell us that they are planar. A, b, and c, because they're on the same line, are collinear. This is plane R, that's the plane, and AC, that would be this line, intersect at point B. We know this because of the dotted line that goes through here. Ray BA, that would be this one, going this way, and ray BC would be that one going this way. Those would be opposite rays, just taking the vocabulary term from the last set of notes. And then X, B, Y, and C. Well, these 3 are all on plane R. C is not. So those would be non-coplanar. coplanar. Just remember, 3 points are always coplanar, but sometimes they can be collinear. And I misspelled collinear. It's 1 N and 2 L's. Let's go ahead and go to the back. So example number 2. Are S, O, Q, and M coplanar? S, O, Q, and M. No. All right. We know that Q, O, and M are on T. S is not. So that means they are not coplanar. Now, we want to name the intersection of planes LON, that would be this plane, plane R, and NQM, NQM, that would be plane T. The intersection of those would be a line UN. Why? That would be planes intersect at a line. All right, part C, name the intersection of plane LNO, that would be plane R, and MN, being the line MN. Well, this plane intersects with this line right here at N. And we would say a plane and a line intersect at a point. Now we look at D, and it says, do S and M determine a line? And they are trying to trick you because there's not a line drawn from S to M. But it's only 2 points. So the reason would be yes, and the Y would be 2 points always determine a line. And now for E. Name the intersection of UO, that would be this line, and MN would be that line, and that would be N. And the explanation is 2 lines intersect at a point. Just reviewing the vocabulary from the other page. Moving on to example number 3. We want to know 3 points that determine J. That would be this right here, and those would be V, W, and Z. Name the intersection of planes J and K. Well, that would be a line, and you could say UW or VW or VU. However you want to name it, but it's this line going up and down. And now it wants a set of collinear points and a set of non-collinear points. Well, collinear would be U, V, and W. Those 3 points make a line. Non-collinear would be basically any 3 points that are not on that line. So I can choose any 3 except for these 3. So I could go V, Z, and Y. There is no line that goes through all 3 of these points. They're not in the same well, they are in the same plane because 3 points determine a plane, but they're obviously not in a straight line. And now for our last question. It says, name a set of points other than those in A that are coplanar. Okay, so we can't use V, W, and Z. So those are out. Well, a set of points that are coplanar would be any three letters. Let's just go U, X, and Y. Any 3 points make a plane. It doesn't really matter where those 3 points are. Any 3 points make a plane. If not collinear. I do have to add that little bit. If they're collinear, they don't determine a plane. But any 3 non-collinear points will determine a plane. Again, this is just applying the vocabulary a little bit. Not a whole lot of calculations. I don't think any calculations so far. So good luck on your assignment and have a good day.